Okay, so here in number 19, we have a circle with a major arc length of 246 degrees. We have a chord, and we also have a tangent line, and the angle between the chord and the tangent line is W degrees. And we're asked to solve for W in this diagram. So the first thing we can do is to assume that this line here is tangent, because our instructions tell us we can go ahead and do that. So when we have a tangent line, we can go ahead and make a 90-degree angle from that tangent line through the radius, and we'll go ahead and just extend it all the way to the other side of the circle. Now, what that allows us to do is we can plot our center point here and then create another side over here using the same radius length. So we now have two radii connecting this chord, which goes to this tangent line to angle W. Because we have a triangle here that is made up of two radii of the same circle, I also can conclude that this triangle is an isosceles triangle with two sides that are congruent and two base angles that are also congruent. And that's going to be part of our angle W. So, because we know that this arc here is made up of a central angle that's 246 degrees, this other angle here that is not made up from that central angle at this point right here is going to be 360 minus 246, which would give us an angle of 114 degrees for this triangle. That's helpful because we can now then subtract 114 from 180 to get the total of what these two angles should be. When we go ahead and subtract that out, we get that those two angles right here should equal 66 degrees total. And since they are equal, each angle equals 33 degrees. Now, going back to our tangent line here, if we know this angle here is 33 degrees, and this angle, because it's tangent, is 90 degrees, we can add the 33 and the 90 to get angle W, and when we do that, we get an angle of 123 degrees.